Centripetal force is that component of force, okay, acting internally, inwards, okay, inwards. So whenever the object moves in a circular motion, that component of force which is acting inwards is the centripetal force, and this is direction is always toward the axis of the rotation or axis of the curvature, rotating across the center. So that force which is acting toward the center is called the centripetal force. Okay, obviously the SI unit will be Newton. Why? Because force, this is the type of force only, so the unit is Newton. Okay, so we will discuss more on the centripetal force is always directly perpendicular to the direction of displacement. See, the object is rotating here. This is the displacement direction. So if you see, the displacement is this side, the force is this side. When it comes here, the displacement is this side, the force is here. So if you see, the tangent always makes 90 degree with respect to the centripetal force. Is it clear? Is it clear?
Yes. Yes.
If an object accelerates according to the changes of velocity, then it can change either its speed or the direction of motion. In simple terms, if any moving object in a circular path is constantly changing its direction, it means it is accelerating. We discussed in the last class. Yes or no? Acceleration is nothing but changes in the velocity. Even though the speed is constant, the direction is constantly being changing, the body is constantly accelerating. So remember, the circular motion is one of the accelerated motion. Is it clear?
Yes, sir.
Yeah. Any doubts?
No, sir.
Using Newton's law of motion, if an object is traveling in a circular path, it is found that the centripetal force of an object moving in a circular path always acts toward the center of the circle. That's all. So how do we calculate? The centripetal force is calculated on the basis of product of the mass into square of the velocity divided by the radius. mv square by r. Okay. And this is equal to m into AC. What is AC? It is nothing but the radial acceleration. Radial acceleration. A is nothing but v square by r. So if you substitute the value of v square by r in A, then you get mv square by r. So F CPF is nothing but mv square by r. Is it clear?
So this is for finding centripetal force, right?
Yes. So you know the
Oh,
mass of the body, you know the tangential velocity. Tangential velocity means the velocity in this direction, and the radius. Then you got a centripetal force. Okay. So more the force, more the mass, more the force, and more the radius. Yes, the force will reduce, and more velocity is the if you want for initially the velocity is v, it becomes 2v, then the force will increase to how much? 4 times. Why? Because 2v whole
so
square is nothing but 4v square. So if the velocity changes double, the force will be 4 times. Is it clear?
yes, sir.
So some of the examples can be spinning of a ball on a string, or twirling a lasso, turning a car, going through a loop in the roller coaster. Roller coaster. Have you seen roller coaster? Going in a roller coaster. Okay. So all these are example of centripetal force, and also planets orbiting around the sun. Clear? So all these are examples of centripetal force. Then what is centrifugal force? Centrifugal force, SCFF. If an object moving in a circle, it experiences an outward force. Whenever the object starts to go in a circle, it will experience an outward pull, outward force. That outward force is nothing but the centrifugal force. Okay. So initially when the object starts to rotate, it will feel, but later on when the objects has a uniform speed, the speed becomes uniform, then the centrifugal force is what? Negligible. It is basically what happens? it is cancels out. Why? Because the force, the outward force and the inward force get cancel out. You don't feel that. So initially the centrifugal force is felt when you start the circular motion. Clear? So if the
Sir, can you
object,
explain that again?
centrifugal force is nothing but the outward force which is felt initially when the circular motion starts. But once the circular motion becomes a uniform motion, when you say uniform motion, it gains uniform speed, the centrifugal force is no more felt. So if you write the definition of the centrifugal force, you can say that the centrifugal force is a force that arises from the body's inertia. Why body's inertia? You know that when you're traveling in a bus and you are sitting quietly, when the bus starts, what happens? Are you not what do you call that? You are pushed. You feel the pull, no? You are pushed backward. Yes or no? Why? Because the inertia of the rest. Similarly, the centrifugal force arises from the body's inertia and appears to act on a body that is moving in a circular path which is directed away. Write down. You can write down the definition. Centrifugal force is a force that arises from the body's inertia. That arises from the body's inertia and appears to act on a body that is moving in a circular path, appears to act on a body that is moving in a circular path which is directed away from the center around which the body is moving. Around which the body is moving. Have you written down?
Yes, sir.
So again, the SI unit will be Newton because again it's a force. And what will be the unit? This unit will be minus mv square by r. Now you say why? Why? Because the centrifugal force is the opposite to the centripetal force. So only the direction is changing. Is it clear? So dimensionally, magnitude, if you want to find out the magnitude, it is the same as the centripetal force. Why? I told you when the body starts rotating after some time, the centripetal force and the centrifugal force both cancels out. Rather, we may say that the magnitude of the centripetal force is equal to the magnitude of the centrifugal force. Only the minus sign tells about that the direction is what? Opposite. The opposite to the center. It is outward. Is it clear?
Yes, sir. So, but I'm confused between tangential force and centrifugal force because both of the
I
force are outside the circle, right?
tangential force. Where did I say tangential force? I said tangential velocity. The
So
body.
not now, but in the centripetal force, there is a tangential force, right? And
No, no,
centrifugal force
no,
is
no,
also.
no, 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 no. The centripetal force is acting toward the center. The centrifugal force is acting outward. This is the tangential velocity. The force, you may say that this force is tangential force, which when it's rotating. So you may say there are three forces. One is the tangential force, the centripetal force, and the centrifugal force. Now you will say, sir, why are we discussing? Because these two forces are actually exactly opposite to each other. So ideally, see, if your centripetal force is greater than centrifugal force, what will happen? The body will not rotate, the body will fall towards the center. If the centrifugal force is greater than the centripetal force, so what will happen? The body will go outward. It will not rotate in a circular path. Since both the forces are cancelling each other, it is rotating in a circular path. Is it clear? Is
Yes,
it clear? Harsh, clear?
yes, sir. Yes, I understood.
Yeah. So both the forces are exactly opposite to each other, a same magnitude. Okay. So, centrifugal force is outward pull, centripetal force is the inward pull, which is responsible for the radial acceleration. Okay, so there are two types of acceleration: radial acceleration and tangential acceleration. Radial acceleration means toward the center, and the acceleration which is directing in this side is called the tangential acceleration. So we will talk about more on that. So just currently you just follow this. Is it clear? So now we will
Yes,
go
sir.
to the next topic. We will see about the applications of circular motion. So what is the application of circular motion? So we'll go, the first application of circular motion is nothing but the vehicle around a horizontal track. You have a horizontal track and you have a vehicle or a car rotating in the circular path. Okay. So we will see how we are going to discuss. So let us assume that your circular path is like this, and your car is here like this, with this, and you know that very well the car has a weight which is downwards, and when the body has a weight, it will have a normal force in the upward direction, and this is the center of the, basically it is like this center, this car is here, so the center, this is the radius, center of curvature. Okay, and this is the radius of the circular path, so the circular track. Okay, and what else, there will be a friction, Fs, basically it's called static friction, which is opposite to the, acting opposite, because it will always try to limit the what, the turn. Okay, the static friction is exactly directing inwards. Is it clear? Now you know very well that N is equal to mg. Why? Normal reaction is always equal to mg. Okay, and this static friction is actually opposite to the what, centrifugal force. Why? You know very well that what is the, if, which is the force which is exactly opposite to the static friction, is the centrifugal force. Why? If it is not equal, then what will happen? The object will not rotate. Object will either stand still or it will go out of the track. So there has to be, you know very well that whenever we talk about a motion, the forces are actually balances each other. So the N is exactly opposite to mg, and Fs is opposite to the centrifugal force. Clear? So we will write the two equation. One is weight is equal to N, and your Fs is nothing but mv square by r. Is it clear? Is it clear?
Yes, sir.
So
Yes,
we will divide 1 and 2. So if I divide Fs by N, Fs by N equal to mv square by r divided by mg. Okay, so goes, so this became Fs by N equal to v square by rg. Okay, so what will happen? V square by rg. So now what will happen? Obviously N is a constant, and your Fs, we write the Fs as mu into N, mu s into N. What is mu s? Mu is the coefficient of static friction, and N is the normal reaction. So we will substitute mu s here. So mu s n divided by N equal to V square by Rg. So N cancel. So what is V square? V square equal to mu s Rg. What will be your V? Your V will be mu as root over of mu V s Rg. Understood? So what is this? What is this velocity? This velocity says that it is the maximum possible velocity which the body can rotate. Aram se. Okay. If you go above this, velocity, what will happen? The body will not rotate. It might turn over. It might, what will topple down. You cannot rotate in a circular path. Whenever you get let's say you are traveling like this in a circular track, and immediately there will be a complete turn. Are you going to travel in the same speed, or you will try to reduce? How do you do that? You always try
I
to
will try.
reduce. Why? Because you are traveling, when you're traveling in a straight road and you are traveling at a very high velocity. But the problem is there will be a minimum velocity, maximum velocity which you can safely take a turn, and that is called maximum possible speed, MSP. So that is nothing but mu s rg. Write down, you get problems on this and also test. Okay, maximum speed, maximum speed. You cannot go more than that. If you go more than that, what will happen? The body will topple down. Is it clear? Is it
Yes, sir.
clear? So now we will go to the next application, that is well. What is well? Maut ka kuan. If you have gone to any, if you have gone to a circus, have you seen the
Yes,
performers?
sir. Absolutely.
Yeah, performers will have a bike and they will start rotating, and then they will start coming, and they will be rotating almost here. Yes or no? It's called what? Well of death or Maut ka kuan in Hindi. Well of death, well of death. So we are going to discuss how they are able to achieve that. So whenever we will draw the diagram, we draw the figure. This is the well. So when, let's say, the body is here, the mass, the weight is downwards. Okay, and because the surface is here, the friction is this side. Why? Because the mg is this side, friction will be opposite to that, and the n is this side. Why? Because this is the surface. You know that the n is always perpendicular to the surface. Always. If the surface is like this, n is like this. If the surface is like this, the n is like this. Did you understand? Did you understand? Why?
Yes, sir.
And what is the force? What is equal to n? N is nothing but the centrifugal force. So friction is equal to mg, and your mv square by r equal to what? N. Clear? Clear, no?
Yes, sir.
So what we will do now, here the problem is that, no, the problem, now tell me, if there is no friction, what will happen? You just think, if there is no friction, what will happen? Will the body be able to rotate?
No, sir.
Will the body be able to rotate? No. No or not? If there is friction, the friction is
No.
not there. Huh? If the friction is not there, then what will happen? The body will be completely fall down. It will not rotate. It will fall down. Because there is a friction, it is actually holding the body. It is not allowing the body to fall down. And the performer is able to safely able to perform the stunt. Is it clear? Is it clear?
Yes, sir. Yes, sir.
So again, we will try to equate. So your Fs mg equal to Fs, and your mv square by r is equal to n. So what is Fs? Your Fs is nothing but mu s into n. So divide. If you divide mg by mv square by r equal to mu s n divided by n. So nn goes, goes. So that becomes what? That becomes mu s. So if you take that side, so g is there, no? G by the r will go, so v square equal to mu. So
RK upon B square.
if you take that side, it will be mu v square equal to mu rg. Mu rg, no. Gr by mu. Yes or no? Gr by mu. Yes or
Yes,
no? What is mu? Nothing but static friction. Gr by mu. So what will be your v square? Your v will be gr by mu s root over. Is it
root.
clear?
Yeah.
So
Yes, sir.
this expression tells that this is the minimum velocity by which the performer can able to achieve the stunt. Able to achieve the stunt. Why? You can go more also. If you go more, then also you will be able to. If you see in the performer will, when it is slowly, it is not able to go. Moment he starts accelerating faster, then only he will go up. Yes or no? The performer has to have a higher velocity in order to rotate, in order to get attached to the wall. So this is the minimum velocity which the performer has to travel. Then only he will be able to achieve the circular motion. Then only able to perform. Is it clear? Is it clear?
Yes, sir.
If he
Yeah.
goes below that, the performer will fall. Why? Because if it goes below, then what will happen? The centrifugal force will be less, and the centrifugal force is less, the normal force is less. Friction, weight will overcome the friction, and the body will fall down. He will not be able to perform. So whenever he has to come down, whenever he starts, he will start like this. Slowly will start, and then he will gain, and then he will rotate. And after some time, when he has to come back, he has to slowly reduce the velocity. Then only he will come down slowly, 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 slowly. And then also he will go, and then he will stop. If not that, immediately he will stop. He'll fall down. Understood? It will never happen like that. Is it clear?
Yes, sir.
Okay. So we will continue in the next class. Okay. I need to go somewhere.
Yes, sir. Sir, I wanted to ask you that